Did you? Okay, so we're gonna start doing the review questions from problem set 5. And did you guys have any specific problems from problem set 5 that you wanted to go over?
Number 5.
Okay. Does it really say number 5? Oh, yes, it does. Okay, sorry. So we're going to talk about Melissa.
I don't want to hold up the meeting. Go ahead. Go ahead without me.
Okay, we are. So let's talk about Melissa. Okay, so on question 5 of the review section in problem set 5, Melissa operates a business in Pleasant Grove. She sells hand-carved business card holders. They're probably lovely. Her good friend Sarah is an aspiring economist and has calculated the demand for one of the products to be 100 minus 5p. Supply for this product is 30 plus 6p, 31 plus 6p. So do you guys remember how to find the equilibrium right off the bat? Okay, so to find the equilibrium, you're going to want to put supply and demand equal to each other. And this works out because what you really want to see is when are they equal to each other? Because at equilibrium, those two lines are in the same spot, so they are equal to each other. So you're going to do 100 minus 5p. Sorry. Is equal to. You can move on now. Okay. It might be Catherine. Turn off one of your computers. Turn off the one that's not working.
Okay, it's because I've got us on in 2 places, so I'm gonna leave the meeting here.
Yep. Okay, so to find the equilibrium, we put we put supply and demand equal to each other. So that's 100 minus 5p equals 31 plus 6p. So what's our next step? Somebody tell me. Okay, so what are you going to do for that? Okay, so we have 100, so we'll add 5p to both sides. And we can do 100 equals 31, and like you said, that ends up being plus 11p. And then we can take the 31 over, so it's 100 minus 31. Okay, so 69 equals 31. Oh wait, no. We subtracted the 31 from both sides. So 69 equals 11p. And so then what do we do? Yep.
Divided by 11.
Both sides by 11. And so what's 69 divided by 11?
Find out. $6.27272727.
Yep. Okay. So here's our answer there for P. And so then what do we do to find? Yeah, so this is the equilibrium price. So what do we do to find the equilibrium quantity now? Any ideas?
You go back to last week's assignment, right?
Yeah.
So quantity equals. Oh, but last week, okay, the difference is last week they were giving us.
So these formulas at the top pretty much are quantity demand equals 100 minus 5p, and quantity supply equals 41 plus 60. So what do we want to do to find the equilibrium quantity?
You solve for quantity supply. Have we got a price yet?
Yeah.
So you're going to stick the price in. You're going to solve the equations at the top.
So that we're all kind of on the right page. We're going to want to replace P with the equilibrium quantity. Or not with the equilibrium quantity, but with the equilibrium price. So we found this equilibrium price. So let's do the quantity demanded. So quantity demanded equals 100 minus 5. And then for P, we're going to put in the equilibrium price that we just found. So what is 5 times 6.273? You want to grab that for me?
I'm getting it. Is 31.365.
31.365. Okay. And then what is 100 minus 31.365? Okay. So it's 68.64. And voila. And this quantity is the equilibrium quantity. So you don't have to say like quantity demand. You use the demand formula, but if we did it with the price, with the supply formula, we'd come up with the exact same answer. So here we are with our equilibrium price and quantity. Voila. Do you guys understand that? Everybody feel like they got how we got there? Okay.
So then when we craft it, we just go like this, 68, 64, and then we put the 6.
Yeah, so to graph it, remember we put the price on this side, quantity on this side. And what was our equilibrium again? What was our equilibrium price? Okay, so let's just do 1, 5, 6.
Why couldn't we do 2 for the equation?
I don't know. I'm just kind of making it up.
No.
Oh, on the TLEs it's different, but for the problem sets, tick marks are totally fine. In class, he told you not to do the tick marks. It's hard to draw on. Okay, so
we need to obey Professor Turley in case he's listening to this.
He's not listening. We'd be able to see him on the side. I guess he could watch it later, and then I'd be in trouble.
Okay, so
yeah.
So is that equilibrium, or is this?
No, so it's probably going to be somewhere around here. Yeah. Okay, so, and then what was the equilibrium quantity?
Was 68.64.
Okay, yeah. Okay, but yeah, so it actually would be this because this line is not real. That's not a good one. So let's do.
So is it going to go like this? Or is it...
Okay, so so here's our equilibrium, so we know there's a point right here. And this point applies for both graphs. Both the supply and the demand. Both of those lines will go through this point here. Okay? Yeah. Yeah, so it's going to be off by a couple points because we rounded when we found the price. And as long as you're pretty close, everybody's going to come up with a couple points different because of that rounding. And that's totally fine. Yeah. Had you used the number exactly as it was with the infinite 2323 behind it, they would have come out exactly the same.
So am I doing a line like this then?
Well, I don't know because sometimes you think that supply always starts right here, but that's not true. It doesn't always start right there. So you need to make sure you calculate supply because it doesn't always start in the corner there. Okay, so our formulas. So let's start with demand first, which was the 100 minus 5p. So let's figure out what the quantity is when p equals 0. That's called graphing the line, and it's just a step in graphing the line. So I wouldn't say that step has a name exactly. Yeah, just because the math is easier. Math is easier with 0. I'm so grateful they invented that number. Okay, so when the price is 0, the quantity is 100. So we can graph that line here. So 15, 16, okay, and now that we have 2 points, we have the equilibrium point and this point right here. We can actually graph this line right now. You can also find what happens when the quantity equals 0 and the price that it's at, but you don't really have to do that step unless you feel like it. Oh yeah, so I guess really I guess I got the I forgot what the equilibrium quantity was. Yeah. Yep, you guys are doing this right. So it's really at this 68. So you graph the point right there. Then you would draw the line from between the 2 points.
Okay, from 100 to, so 100 is 1.
But you can't tell the number just by the line, just because we're being inaccurate in measurements, right? I mean, as far as we know what the 100 is, but we don't know at the end of the line of 100 what that really is.
No. Yeah, we could calculate what that is if we wanted to. We could calculate.
But we couldn't get it from the graph.
No. That's well. So if to get this line where the demand hits this line here, we would put quantity equal to 0, and that way, and we can do that if you like, and so you would end up with the 0 equals 100 minus 5p. Take that 100 over. You have negative 100 equals negative 5p. Divide them both by negative 5. And what's 100 minus divided by negative 5?
20.
Yeah. So we can calculate what the price is up here. And it's going to be 20. But because our graphs are inaccurate, we can't just see it using the graph. And economics is all about, just knowing the theory. And there's some knowledge of numbers, but you just have to kind of, the graph is just there to give you an idea of what the numbers will be. But to calculate the actual numbers, you do need to use the formulas. Does that kind of make sense?
Mm-hmm.
Okay, so let's graph supply. And did you have a question?
So that's my demand.
Yeah, that's your demand. Okay, and supply, the formula was Q equals 31 plus 6p. Okay. So what should we do?
You know the price?
We're going to try and graph this line. And remember, this point right here still applies to the supply.
That's what we're doing.
Yeah, well, first we've got to, yeah, which one do you want to set equal to 0? Yeah, we can do that. So let's put price equal to 0 and see what the quantity is in price.
31.
Yep, okay. So we know that when the price is 0, the
31.
quantity demanded is going to be 31. So it's going to be right here. And then, since we have 2 dots in this line, because the equilibrium is the same, we can draw a line between these 2 dots. And voila.
Okay, 30 is down here.
Mhm. Yeah. And this is one of those cases where you have to remember that just because it's supply doesn't mean that it starts at 0. This could be some good, what good was it? Business cards?
Yeah. The lovely business cards.
Yeah, where even when the price is 0, she is still willing to produce 30 because she just likes to make them. I don't. it's an odd craft, but don't always assume. Of just like putting numbers into it.
Okay, so what is this called right here?
That is a point on the line.
Oh. Versus.
Another point on. Okay,
so
wait.
that is not.
No. So this dot should be right there. Okay, so she kind of drew a line a little bit early. She has an extra line in her graph because of. Okay, so you made the mistake of, which is totally common, and I actually was
Just
prepared
say
for
good
this.
try. That's what he says when
This
he
was
means
it was
no.
like really a good try. But up to this point, most of your graphs, the supply line has started right here. But this one didn't start here because when price was 0, it started on 31. And so she started here and kind of went up to this line. Yeah. And this
So
is kind of like
is
my
supposed to go like this then?
yeah, it could be go to the equilibrium point. So go from
This?
yes, exactly.
Oh my gosh.
So you would go from the point where quantity is 30 and price is 0 to the equilibrium point, which is common between both lines.
And this is my supply line.
Yes. Yep. So this is the supply. And
then that is the equilibrium.
And this is the equilibrium.
Now this is supposed to be an easy question.
Yeah. You did great. The fact that it didn't start. Yeah. The fact that it didn't start in the corner was kind of meant to trip you up and to show you that it doesn't always start in the corner. Yeah, essentially we're just finding a point in the line. And because we could have used any other number besides 0, we could have used, 100. And no, if you put any number in for P and then calculate for Q, it will be somewhere in the line. It might be like way up high in the corner and you won't want to grab that point. And we often use 0 because it's just easier to calculate and easier to see on the graph, and we know that it's going to be there.
Okay, so would we be willing to pay $30? $30?
No.
She's willing to make $3
Right. So the next question on the problem set asks, you are someone who would like a hand carved business card holder, and the price is $30.
So is it a good decision for me to buy from Melissa?
Mm-hmm.
Probably she's gonna do it for free.
Well, but she's not doing it for free. She's charging at $30. Okay, so let me make. Okay, let me see. Oh, right. Okay, so let me rephrase the question because I think I didn't say it properly. You happen to be in the market for a hand-carved business card holder, and you would be willing to pay $30. Okay. So you're willing to pay $30, but oh, sorry, something happened here. But she's probably only charging right here at this point of $627. I'm
On the computer.
right now. Oh, sorry. So I'm
Oh yeah, 6273.
yeah. So she's charging $627 because usually people will automatically charge this price at the equilibrium. But you would be willing to pay $30.
Well, I mean, it sounds like a good deal.
Yeah, that's right. You would be willing to pay $30, but she's only charging $627. So
This is the CS.
yeah. So this up here is the consumer surplus, and then this down here is going to be the producer surplus.
Okay, so is it all of this here or all of this?
It is all of this. So it is this. It is
And that triangle?
no. It's not this triangle. It is this trapezoid. I think is the name of this shape here, with 2 parallel lines and 2 not parallel lines. So this is the producer surplus, and then the consumer surplus is this triangle up here.
This section right there.
Nope, it's not this section here. So the producer surplus, and one thing that's really important here is the price. So the price is kind of what separates everything. Think of a person right here. This is me. This red dot here. Because my name's all red. So this dot here is me. I would be willing to pay this amount right here, this price PA, and be happy. But I end up paying this price here at the equilibrium. And so I have exactly this much surplus. This distance from here to me is my surplus. And there's another person here. And this is my husband. And he would be willing to pay price husband. And the distance between him and the price that he has to pay, that is his surplus. So imagine there are people all along this line. There's a person at every single point of this line, and each of them is getting exactly the surplus that fills the area here. Yeah, but those people won't buy anything, and so there's no surplus created. Okay, so but for our friend who's making these things, this one for 10 business card holder, she would be willing to give it away for nothing, but instead she gives it away for $6. That's great. And so all the area between here for this 6-1 and the price that she pays, that's her surplus. Does that kind of make sense? But this one that her 50th one, she'd be willing to sell for, it looks like about $4. So the distance between the 4
And the 10.
and the $4 and the $6.27 that she gets for it, that's the surplus. Okay, so that's just kind of, I don't know that that helps you with the problem, but it kind of helps you understand the surplus. So you would look at, look at these lines and say, what's the distance between what they would make it for and what they would sell it for? And that's surplus.
Okay, but we only have like a few minutes left.
Mm-hmm.
Can you tell us the difference between a federal program that's elastic and highly inelastic?
Okay.
Because I don't understand that.
Mm-hmm.
But a federal program, do you talk about federal program? Oh,
Yeah,
But
so the
that's a
question in the
question.
problem set asked about
on number
a
3
federal
and 4.
program that's highly elastic. So, can you think of a federal program? So, can you tell me what it is when something is highly elastic? Do you remember what that is? Anything?
Well, inelastic is less than 1. You raise the
Right.
price to inelastic.
Right. So, but what does it mean when a good, like without the numbers, what does it mean when a good is elastic? Any idea? Remember? Okay, so you guys are so on the right track. You're on the right track.
Good try.
Good try. See, I have my own
means
phrase.
no.
I have my own phrase that I say. So when something is elastic, yeah, when something's elastic, it's more volatile. So when something is elastic, that means a change in price drastically changes the quantity. So what is something that if they raise anything, not just a federal program, but what's anything that if they change the price like a couple of cents, you wouldn't buy it anymore?
Oh, well.
Or even a few couple of dollars.
Oh, yeah, he used that in class. What?
I don't know, it's going.
Yeah, okay, so they use the parking tickets here
Mhm.
now that you have to buy a parking permit here at BYU. They set it at $60, but if
Mhm.
it was $2,500, nobody would have paid for the permits.
Right. So when something is elastic, a change in price, even a slight change in price, drastically changes the quantity. So I think of like movie tickets, like opening movie night.
Oh yeah,
tickets.
Premier.
Like a slight change in
Drastically
price drastically changes the quantity. So like movie price tickets, I mean they used to be like $5, and they went up, and then they've gone up, and like
Yeah.
every dollar. I haven't been to a movie in the theater for like a couple of years because I just can't
Wow.
stand paying.
And I go to Premiers all the time.
Right.
They're $15 for a like $8 seat the next day. You know what I'm saying?
Yeah, and
But you go, I'm
Right.
willing to pay because it's like a party.
right, but this is something that's elastic for me. Movie tickets, I'm highly elastic when it comes to movie tickets.
Yes, see.
So is there like something with yeah, because even changes in the gas, people still buy a lot of it. They have to. And help. Mhm.
Oh, well,
Right. So like gasoline is something that's inelastic because even when the price changes, you're still consuming the same
yeah,
quantity.
insulin.
Insulin. That's a great example of something that's
You have to
inelastic.
have it.
Yeah. Yeah.
And you don't have to have
Yeah. So maybe you could say like a national park tax. If the price goes up, I'm less likely to decrease my visits to a national park.
Okay.
And there are probably a lot of others. There's probably a lot more with the federal government when it comes to inelastic, like student loans. Mm-hmm. Yeah, so if the federal government changes their rates on student loans, it could drastically decrease or increase the number of students getting
So
student loans
what-
because of
So
other.
those are things that it's not like you have to have.
Yeah. So usually
You
things
may
that,
have to have it in your
yeah.
Yeah.
So things that are highly elastic are usually things that, like Travis said, things that you don't really need, or like luxuries, or things that there are other options for them. So, like if the price of ice cream goes up, I'm gonna start buying popsicles instead,
Yeah.
because and that means it's elastic if I stop buying it when the price goes up. Or
So that would where your
Yeah.
substitutes would come in.
yeah, or like French Toast Crunch, which is like one of my favorite cereals. When the price goes down, when they're on sale, I buy a lot of it,
So
and
what-
so that means I'm highly elastic.
What's a
to it
federal
because-
program though besides gas? I mean, that
Gas
is
in it.
So gas would be
inelastic, that's what I'm
inelastic.
saying. I can see that with highly elastic, but inelastic.
Yeah.
You know, what's a federal program we have to have?
Like what do you guys think? What's a federal program that people who need it?
Well, like the welfare program, you mean?
Yeah,
Oh,
healthcare.
healthcare is a good example.
Healthcare is exactly right.
Well, it is.
But you know, like
Some might
people
not have
people
options.
who have to go through Medicare,
Yeah, Medicare.
yeah, they don't really have other options that would be as practical. So even if the price changes, you're still going to have a pretty similar number of people on Medicare. Exactly.
Okay.
So do you feel
Yeah,
like you understand
yeah.
the concept of elastic
Mhm.
and inelastic?
Elastic, I'm gonna think of the luxury thing. Something
Yeah.
you could get a substitute for.
Something you need a substitute for, or you don't really need it.
And inelastic is something you have to have, like the insulin.
Yeah.
Yeah.
Like,
Right.
mhm. Okay, you guys feel good today?
Yeah, I feel better.
Good.
And,
That's good.
yeah, how many minutes? Yeah,
I have 3 minutes.
3 minutes. Okay, can you talk about revenue?
Okay. So
This is
on
number
problem number 1
one.
in the review problem set. So
It was
so if we go to problem set 5, review question number 1. The first one talks about the price elasticity of demand, which we talked about in the last video that I did. So you would calculate that, and then the change in revenue. So what you're gonna want to do is okay. So at the first price, at $8, they sold 250 fishing licenses. So what's 8 times 250? 2,000. And okay, so do you guys so the revenue when the price is $8 is 2,000. Do you guys understand how that happened? Because we multiplied the price by the number that they sold, and so that came up with the revenue for when the price was $8. So how would we come up with the revenue when the price was $10?
So 10 times number sold.
Okay. So and that's going to be 10 times.
250.
So but this time they didn't sell 250. When it was $10, they only sold 204.
So 2,040.
And so when it says, what is the change in revenue to the state if they implement the increase? Yep, $40. Because you just say, well, now it's 2040, and before it was 2,000. So the increase was $40.
So the difference.
Yeah, so that's just saying the difference. And it does go up, so you would say, I'll give $40. Everybody feel good? Okay, thanks for coming and asking questions because that really helps me. Do you want to be in the video at the end?
And we sure want to thank Andrea for just a great experience here learning.
I try.
So everybody go do your homework. See you in class.
Okay, thank you.